Okay, this is a pulverizer startup video in a coal plant. Right now the BAO has called, Balance Authority Operator. He's requested the plant to go to 500 megawatts net. We have 4 pulverizers running right now. The bottom 4, we're going to start C. The problem with the plant, 4 pulverizers, we're going to go to 425 megawatts, and 5 pulverizers, you're going to go down to 400 megawatts. So we're sitting right between the two ranges. It doesn't give you a whole lot of time to move when they request a load change. We're going to go to 500 megawatts net. The plant takes about 28 megawatts at this load for in-house use. So I'll type in 528. Okay, we're going to hit go. We're going to go 3 megawatts a minute. Okay, it's taking it. We're going to start C pulverizer. We know we have coal in the silos. There's C pulverizer silo. It has 400 tons of coal in it. Okay, first thing we'll have to do is inert the pulverizer. Uses steam. We'll flood the bottom of this to get rid of any hot spots or anything that may cause a problem during startup. The inert will run for 120 seconds. We have the inert started. Down here's the timer. It is inerting. Like I say, in this plant, red's open, green's closed. The next thing we'll do is have to start the igniters. A nice thing about this, you have your start ready screen. Just leave dampers not in light off, everything else is made up. Here's another screen for starting them up with. You can change all your sleeve dampers to light off. This screen has all the valves on it and everything you need to adjust for startup. But we'll use the graphic screen, it's easier to track. You can do the same thing on this screen. As you can see, the sleeve dampers are moving. They should go to about 30%. This is the secondary airflow going in past the burner. We have inerting steam temperature coming in. Once all these make up, we can go to the igniters. We're getting the start ready lights in. Okay, we've made up all the permissives. That's really handy having all the permissives on a screen like this in case something has failed. Okay, we're going to start the igniters. Usually start one at a time. Give it a little bit for the fuel oil pressure to catch. These burn diesel. Take about 3.5 gallons a minute each igniter. Okay. Here you have your igniter. The igniters extend in. They have to be in all the way for them to light. We have the igniter air valves open. The fuel oil valve has not opened. Come in, Brian Davis.
Go for Brian Davis.
Pulverizer C, Charlie 2, igniter has failed.
Okay, I'm right there. I'll take a look at it.
Sometimes you have to push them in. Other times they start carboning up. You have to play with the fuel just to get them to light so you can clean them later. High drum level and low drum level also will lock out the igniters. Okay, we're about 4 megawatts away from...
Control room, got a copy? Control room?
Yes, control room.
I think I got that igniter freed up. See if it goes in now.
Okay, starting igniter. We're showing it worked. We still have the stop in on it. Okay, we have a problem in the logic. The valves open out there, okay?
I'll recheck it. It looked good, but I might have to check it again.
Okay, I may have to restart the igniters. Okay, we're showing it does not see the igniter oil valve is open and shows the flames not detected. We got about 1 megawatt and then we're going to hit a block on it. So let's go ahead and kill everything and restart it. It'll trip the igniter fuel valve. We'll get an alarm on that. Okay, igniter fuel valve tripped. Back to start ready. They're trying to relight. We're showing a flame on them, all 4 of them. Okay, we got it now. A little problem in the logic. Or something, it wasn't seeing something out in the field one the limit switches may not have made up. Startup screen, this is the one I usually like to use, but we'll use the graphic screen as it makes more sense. This line here is the seal air. This provides air to the table seal, the roller bearing seals, classifier dampers, keeps the coal dust out of all the bearing areas. We'll look at the LDC. Okay, that's all the nozzle temperatures. Once you open the seal air, allows all your temperatures to come in, all the different burner nozzles. Okay, we've hit a block. It stopped at 426 until we get another pulverizer running. This is the Paso primary air shutoff damper. This is the main air going to the pulverizer coming off the primary air fans. Runs about 56 inches pressure, about 3 pounds. The open race, we open this. It helps also open the guillotine. This is a motor driven guillotine damper. It's a big flat plate that goes across. You definitely want to shut the air off tight to these things when they shut down. Sometimes you have a problem with these opening or not making limit switches, but it looks like it's worked. We're going to put a little bit of air on it before we open up the burner shutoff valves. It requires 10% airflow for the pulverizer to start damper position. This is the flow control damper we're moving right now. Usually around 70,000 pounds of coal, you want about 170,000 pounds of air. Now the burner shutoff. These are individual valves on each burner duct. See, it's yellow, it's traveling open. These sit right on top of the pulverizer. A bunch more nozzle temperatures coming in. Look at the burner temperatures. They should be dropping. You want to be careful not to throw a bunch of coal out there on really hot burners. You can coke them up. Down here we have a start ready for the pulverizer. Primary airflow is less than 10%. We'll need to announce this that we're starting the pulverizer. Attention all plant personnel, starting C, Charlie Pulverizer. Starting C, Charlie Pulverizer. Please avoid the area. It's a good idea to call that out in case something happens starting it up. So we need a little bit more air on it. So what we've done now is aired up the pulverizer. Because basically we have here we have the tempering air damper, brings in cold air. This is bypassing air preheater. Hot air is coming through the air preheater. Be about 700 degrees. Went about 140 degrees on the cold air outlet. You can tell if you've got really wet coal by how much hot air you're having to feed in. The coal is pretty wet coming in. Okay, we got 11%. Okay, we got our start ready. These are all the permissives that have been met. All it takes is one of these to not make up. A limit switch doesn't work. A level's a little bit out. You can't start it. Drum level is important. Get this above 4.5 inches and down to about 5 inches. You cannot start a pulverizer. Okay, we got the start ready. We can start it. It's about 800 horsepower motor, 75 amps. We do have a trend. We can track all the temperatures. It's really important starting equipment to track all the temperatures and any abnormal conditions. This is the boiler fuel gas oxygen. You can see it slightly swings. It's kind of chasing load a little bit. Roller seal air DP. I have good roller seal air flow through here. You got damper positions, cold temperature, air temperature coming in. DP, this is huge. You can tell if the pulverizer is plugging. Cold flow, airflow. Okay, it's running about 23 amps. When this thing is running, you have to watch your differential pressure. If they start plugging, this will start climbing. It's measuring the resistance across the pulverizer. You can get a lot of wet coal in here. That'll cause problems. Not enough airflow. Once you start plugging, you have to cut the fuel, increase the air. Try to get the coal loading out of it. Another problem, they can skid. If your current here stays the same, the rollers, instead of rolling, will actually start skidding. It does a lot of damage to them fairly quickly. Outlet temperature, this is huge. You can tell if you have a fire in the pulverizer. You do have fires in them occasionally. You want this for about 140 when we're running. It's running, we're just giving it a second to blow any coal out of this thing. Sometimes you can grind these to the boiler if you trip off, lose one. You can start up and keep the airflow real low and slowly feed in the coal dust. But if we trip off, they have to grind them out. You put inerting steam on, then you grind it, and all the coal in here dumps out the pyrite hopper. So you basically get all the coal out of these. Okay, here's the coal feeder. The silo sits right above this. Permissives. Only one we're missing is the sleeve damper. We startup have to be 11. Then you gotta be above 29 for the feeder to run. Make sure there's enough airflow. You don't want to dump a bunch of coal in here without proper airflow. You'd plug it up very fast. You want to be kind of careful too when you bring up the air. You're loading the primary air fans. We have a whole bunch of coal nozzle temperature alarms coming in. They all cleared. It's like just about 500 degrees, most of the nozzle temperatures. Now if you move your air too fast, you can reject your primary air fans, which means they kick back to manual, drop out of automatic. On the control system here, we have the pulverizer temperature, airflow, and feeder speed or fuel flow. Okay, that should be good. Check permissive. These are all the permissives you have to have in order to start the feeder. Open the feeder outlet. It's usually a good idea to do this. I mean, some places do it different, but if this don't open and this thing's full of coal, you'll have to unload all the coal by hand. Now we're opening the silo outlet valve. When this opens, coal will be dropping down to the feeder. It's just a belt in here. Maintains a certain amount of coal on the belt, and you change the speed of the feeder determines how much coal is being fed. So there's a weigh scale in here. They'll measure the coal on the belt, and there's a little gate that controls the amount of coal. So you maintain X amount of coal on the belt, then you can just change the speed, and that changes the feed rate. We have our start ready. All the permissives have been met. Okay, we have our start. Feeder's running. A bunch of low flame alarms just came in. This is set to ramp up to about 30,000 pounds an hour. For startup, you can go 20,000. Oh. Okay, so this is 1,000 pounds an hour it's feeding in. We'll go to our flame page. As you can see, we have the igniters running. This is the main flame. This is sleeve damper positions. When they're running, it's like 75 more air goes on the outside of the burners than on the inside. These are 55% open. LDC, we're still blocked. BO should be calling about now, wondering why we aren't moving. These you have scheduled for buying and selling power. Here's the primary air fan. Show this real quick. These are the two fans driving the air to the pulverizers. These motors are 7,200 volt. They're rated 3,500 horsepower each one. These are the control dampers. Right now we have 59 inches water column pressure coming out of them. This is the tempering air. It bypasses the air preheater. We have an air heater system. We call it the FRA. It basically keeps the air warm so you don't drop sulfuric acid, nitric oxide acids and stuff on the plates and air preheater. Coming in the air preheater at 78 degrees. It's only heating at 572 degrees coming out. We need to get this light off, load less than 40% in order for this plant to start moving up towards the 500 megawatts. Usually I give a little bit of extra air right now. Sometimes the flow control damper I can seize because you got all this hot air coming down, hitting it, and it expands. We'll set the pulverized air temperature. We can put in auto, it controls fairly well. We'll bring it down a little bit to 144 or so. This will be the outlet temperature of the air coal mixture leaving the pulverizer. Feeding in here will be a lot hotter because you have to dry out the coal. Like I say, it's fairly wet coming in, so it doesn't have a lot of dust. Okay, we need to get this thing above 40% load. Also, if you lose an igniter right now, you'll trip it. Once you get above 40, you have to lose a second one for it to trip. Okay, the light went out. Plant should start moving again. Need to do about 5 clicks on fuel. About 5,000 pounds at a time. To watch a DP. Here's our trend. See our airflow. Here's our feeder coal flow. We made those 2 moves on it. Damper positions. DP is only 6 inches. That's pretty good. Gets up above 30, you're starting to have problems. It can go pretty fast once that happens. Give another 5 clicks on fuel. There's an air fuel chart we'll use. This should be about 70 and airflow should be about 170. You have to keep your airflow high enough, otherwise you'll plug your pulverizer. As the air heats up and we add more fuel, this will drop off. Should see our dampers moving over here. The tempering air, the cold air is backing off and the hot air is opening up. This is going to try and go to 140 degrees. Temperature has a big effect on pulverizers. Some of them you got to run a little cooler. They make a lot of noise if it's hotter. Other ones you got to increase the heat a little bit on them. So every pulverizer behaves a little differently. Basically, there's a lube oil pump on these. There's a gearbox down here. So you have a lube oil pump that takes the oil, goes through coolers, filters, and back to the gearbox. There's big rollers in here. This one has 3 rollers, fairly large wheels. The table turns and the rollers stay fixed. So it crushes the coal. The air comes through and picks up the fine coal, goes to the top, and there's a classifier. It spins the coal and drops out the larger particulate, drops back down to the table. Up here you have classifier dampers you can adjust to kind of control the fineness of the coal. It should be about like a 200 mesh screen. It's fairly fine, kind of like flour. It gives you a better burn if it's ground to good consistency. At this point, we'll have to start adjusting the sleeve dampers. This puts secondary air in past the burners. As the air goes into the burners, it spins the air. You want to have staged combustion to lower the NOx formation. So it burns the coal in different stages to hold down combustion temperatures. We can also add overfire air to bring NOx down. All the sulfur is removed with a Trona product. We call it DSI, dry sorbent injection. It's using Trona. It's ground fine, sprayed in right before the air preheater, and absorbs all the sulfur. All the mercury is taken out with activated carbon and other stuff added to the coal. So mercury is very, very low. Probably one of the lowest mercury emissions of any plant. Our big emission products are sulfur, mercury, and NOx, and they're controlled very well. The low NOx burners made a big difference. Yeah. Talking too much, not paying attention. We set the outside ones just a little higher than the inside. These can be adjusted if you have a problem with your O2 profile across the boiler, or if you have carbon monoxide emissions. You can also adjust these, try to find the problem. Sometimes burners get an eyebrow across them, they don't burn quite right, so you have to play with the airflow a little bit. There's just a kind of a metal hoop that goes over the burner, regulates the air. These take a little bit to move. I'm glad we have we can use buttons and control them all. Like after purge, you can bring them all back to light off. When you purge, you have to open the dampers up pretty far to blow any non-burn or any combustible gases out of the furnace. This definitely will change the fire. I'm running a little bit higher on the outside edges. Temperature's up to 112 already. 173 coming in. We'll go to the load demand computer screen. Okay, we're at 443. We get to 500. This goes to 520. We'll see where we may have to adjust a little bit to get to the 500 and hold it. But now with 5 pulverizers running, we can go to 520 megawatts. That's here's the acoustic leak detector. This is looking for various tube leaks in the boiler. Looks for acoustic signatures of a leak. Right here's the firebox. This is where the fire's coming in. Division walls, bowl nose, finishing superheat. Comes down your primary superheat. Upper economizer. This is the reheater section. Lower economizer. This is the economizer ash hopper. Then it goes out to lower economizer and precipitator. Primary air fan screen again. Dampers at 45, still 58 inches. 578 degrees coming out. A little bit more heat coming through. We will have to adjust. We have the dampers feeding the various air preheaters. They're 100% open on the primaries. Secondaries are still pinched back a little bit. We'll let this temperature go up more. If it gets too hot, it can cause problems in your precipitator. This is the precipitator. Buildings uses electrostatic precipitation. These are the ID fans. They're variable freak drive motors. So the airflow looks good. We have these dampers full open, trying to get all the heat we can to the pulverizers. The low loads is going to be a problem. You have to play with the dampers and try and get more heat to the pulverizer so the coal grinds well, gets the moisture out of it. We'll go to the forced draft fan. These are the forced draft fans. These are about 2,000 horsepower motor, 7,200 volts. These are working with the ID fans to try and maintain a furnace pressure about a negative 0.5 inches water column. You want your pressure to be slightly negative. The air preheater on these. It's about 537 degrees coming out of the secondaries. Wind box is 1.22 by the time it goes past the burners. These are the burners. And it feeds in past the sleeve dampers in the burners. Look at her. There's the flame screen. We've got 113,000 pounds on. Most of the burners are going to go to 134,000 before they load block. We got one sleeve damper down here that's failed, went closed. We want to get the igniters off as soon as we can. Kind of wasting some time here today, but burning about 15 gallons a minute of diesel. DP still look good on this. DP is good, temperature's coming up. This is the overfire air screen. This is what you use for NOx control. If you get high NOx, you can also put more air over the top of the fire. These you can change the oxygen profile across the boiler with how much they're open, but this is mostly just for nitrous oxide formation. It takes some air away from down below and puts it over the top, lowers combustion temperatures. See, the airflow has dropped off quite a bit. We're going to take the igniters off and then put it in auto. When you kill igniters, you just want to take one at a time and watch the flame. We'll take two first. Looking at another screen. The other one, flames look pretty stable. When they shut off, the fuel valve closes, then the air stays open, blows out any diesel out of the igniters. They're about 12-foot long pipes, and they do build up carbon from the heat. When they shut off, they pull back out about 18 inches, 2 feet, trying to keep them out of the heat of the fire. As you can see, we got the main flame and the igniter flame showing down here also. We have the igniter trip valve. This shuts all the oil off to all the igniter decks, and it just tripped. Got a master igniter fuel trip. Just a safety precaution. Okay, the igniter valve's gone closed. Now we need to reopen, reset it. The igniters are still extended right now. They're blowing out, and they should all retract. This screen shows the same stuff as the mill graphic screen, just a different format. So there's several screens you can use to start these with. We need to match the fuel up to the other pulverizers before we put that in auto, but we'll need to go a little bit more and then put the air in auto. It's best to keep everything in auto when you can, otherwise you forget about stuff, or it's just a lot better way to run. Our DP's looking good, still coming up slowly. 70 on fuel, 170 on air. Probably put the air in auto. This is going to control this valve here off the coal feeder flow. Okay, it moved. We're off just a little bit. But you want to keep the air and coal feeds within specs, or it will plug up the pulverizer. Temperature's coming up good. Motor amps are moving around. This says that it's not skidding, it's grinding. You'll know also when they skid, they make a, it's not like a helicopter taking off. We're up to 471 megawatts. Look at the flames, I guess. Okay, we're almost there. Things around 106. There's 103. As you put fuel on, it automatically backs the other ones down. Same with the igniters. You put igniters on, it backs off the coal feed. The fuel control system works very well. So we're 4,000 pounds off for putting this one back into auto. Okay, from the other screen, they're all equal right now. We can put this in auto. I'm putting pulverizers on if you're chasing megawatts. It depends on the price of power. This plant can go down to 120 megawatts at night, which are 2 pulverizers, back up to 580, which is 6 pulverizers. You can do this twice a day, so it's pretty hard on equipment. Or if you have wind power thrown on the mix, you'll be chasing wind, you'll be running up and down depending on how much wind power there is. So these plants, usually you can count on starting pulverizers in the morning about 4 o'clock, hits the morning peak. And then in the afternoon you have your evening peak around 7, 8 o'clock. But like we started out with, we're sitting right between 2 pulverizer bands. At 4 pulverizers, we couldn't go above 425. And at 5 pulverizers, we couldn't go above 400. So it's kind of a guessing game which way you're going to go. I mean, we could have started in the pulverizer and then went up and not had the block. But if you had 5 running and they want to drop load, then you couldn't go below 400 until you take 5 off. So big things to check: make sure your pulverizer's not skidding. That's the roller's not rolling, they've jammed. Make sure that's not plugging up, a lot of coal building up, you can't get the airflow through it. High temperature, this can mean a fire's burning in the pulverizer. CO, this can tell that you have a hot spot, it's starting to oxidize in there. Watch your damper positions. Make sure something don't try to fail close or it quits operating. Right now we're at 15 on DP. Here's our trends. See our DP is coming down as we start getting more load on the inside and air building up. The coal flow, I can see we brought it up. Airflow. Big thing's a DP. And that's putting a pulverizer on at this pulverized coal plant. These are Foster Wheeler MBF pulverizers. They're a roller type. I mean, there's different types of pulverizers out there. We have 2 of the older style that had the planetary rollers with springs on them, the MB, and then 6 of the lower ones are the MBF, which the rollers are stationary and the table moves. These are a lot more durable. They can take a lot more. They're not as sensitive as the other ones are, the older style.